Now on to reconstructing a fabulous 3D model out of the processed photos in Meshroom. Before we get started, feel free to download this free and open source photogrammetry software from alicevision.org. So the first thing we need to do is import the photos that we processed in Darktable into Meshroom. In order to do that, I'm gonna select the photos from the geometry folder and drag them onto the images window. So once we load up our source photos into Meshroom, we should see it over there. The scale of the thumbnails can be changed if we wish. So these are the photos that we have pre-processed for geometry. We can click this icon to check their metadata and see if everything is alright. For example, it's worth checking the resolution to see if those files are the files that we think they are. Looks okay to me. And now we can press this enticing green button that says Start. Actually, no. We should really use nodes one by one in the graph editor. It's much safer to approach Meshroom in a modular way and activate these nodes one by one until we reach the final destination, which is the texturing node. That's gonna be the last one. But we should be definitely proceeding through this chain on a node-by-node basis. So I'm gonna right-click on the first node and compute it. Meshroom prompts an error that we should probably save the file first, so let's heed the advice. File, save as. Name the file somehow. I won't be insisting on particular naming. Okay, now we can right-click and compute it again, and we can see that the progress bar became green. It means that the node has been calculated. Every node in Meshroom has the attributes that can be changed, and some of them can be seen only if the Advanced Attributes checkbox is ticked. But at the same time, this checkbox makes everything convoluted, and the default settings are more than enough in practically all cases. But at the same time, there are some useful settings that can be seen only with this checkbox set to on. For example, the Force CPU Extraction checkbox, which can be switched off for a slight benefit in speed, but generally it isn't that important to see all the advanced attributes. Well, okay, returning for a moment to describer density and describer quality, these two settings definitely have the most influence over the processing time and the resulting quality of the feature extraction node. I will go with the flow or with their default values, but feel free to experiment. The right-click menu, compute. The progress bar on the node has turned orange, meaning it's processing. Once it's finished, it will turn green, and that's how we know that it's fully processed. Now, for example, we know that every feature has been processed. We can click on the display features icon in the image viewer to see those markers or sift features. Basically, Meshroom detected a bunch of points for every photo, and in the feature matching node, these points will be matched to then create the structure from motion. But first, let's compute the image matching node, then proceed to feature matching. No need to touch the settings, the default values are just fine for these nodes, probably all the way until the depth map node, based on our experience. So right-click, compute. To track the progress, we can head over to the log window, and we will see the chunks there. Each chunk has to be processed until the node is calculated and marked green. And here we can see the progress bar for each chunk as well. The chunks, just like the nodes, are also marked green on finishing. So it took approximately 7 minutes to calculate the feature matching node. I'll be logging the progress, just in case. Then onto the structure from motion node. As you can see, the calculations become progressively longer and longer, and this node definitely will take a considerable chunk of time. Whoop, 20 minutes to be exact. Whoa. It's quite typical for photogrammetry and for Meshroom photogrammetry too, of course. I feel there might be an opportunity to use a wise quote here. To lose patience is to lose the battle, by Gandhi or something like that anyway. But what do we have here? It's our structure from motion that has just finished processing. Alright, we can see the generated result in the right-hand panel. The visibility can be toggled on and off by pressing the eye icon. We can read the number of points there and the number of cameras that have been matched. 107. All cameras have been matched, and that's great. Then in the top right corner of the UI, we can change the scale of the points and the scale of the cameras as well. I try to keep these values pretty low so the viewport doesn't look as cluttered. Alright, by looking at the viewport, we can tell that the orientation of the model is a bit weird. What we can do is add the extra node after structure from motion. In order to do that, we need to create some room. So I'm gonna move it like this to the right, node by node, until we free up some space over there so we can plug the node. Right click on the empty space, go Utils, SFM transform. The SFM data should go into the input. And then right click and remove this existing connection and hook up the output SFM data file to SFM data input of the prepared dense scene node. We can choose from different transformation methods, but let's try auto from landmarks. Hopefully that will fix the orientation issue. Let's compute the node, double click it to open it up. Let's toggle off the visibility of the original structure from motion, and I think something is wrong. Let's try unticking the scale and translation checkboxes and just play with rotation instead. Okay, double click again. Alright, awesome, that did the trick. I think it improved the orientation of the point cloud. It's far from perfect, though I think it can be adjusted furthermore. Say, if we'd like to tweak the orientation of the point cloud manually, we can do it too with the help of the SFM transform node. So I'm gonna repeat a somewhat tedious process of moving it node by node to the right, and then I'll hook up the second SFM transform node in between these two. Something like that. The transformation method now should be set to manual. That gives us a gizmo with scaling, rotation and translation controls, so we can place the mesh, or rather the point cloud, manually somewhere in the scene. Let's toggle off the visibility of the original object and use the gizmo to carefully rotate and translate the mesh until it rests on the grid, like this. There are two gizmos now, one for navigating in the viewport and the second one for rotating the mesh. You can click on this hide gizmo icon to hide it temporarily. Optionally, this alignment step can be skipped altogether, because we will be tweaking the orientation of the resulting model in Blender anyway, but I'm too pedantic to skip it. I really want to see the correctly oriented mesh right here, right now in Meshroom. Alright, after doing the quick alignment, we can proceed to calculating the rest of the chain. Preparing the dense scene for depth maps won't take long. Just a few seconds at max. But then it's time for the depth map calculation. That beast can definitely take an insane amount of time, especially if the downscale is left at 1, meaning the original resolution. In other words, if the downscale is set to 1, Meshroom divides the source photo resolution by 1, meaning it uses the originals. If the downscale was set to 2, Meshroom would divide the resolution of the source photos by 2 before processing the depth maps. If the factor becomes 4, Meshroom downscales it furthermore. Now it is a rhyme. Let us go with the downscale of 2 though, taking into consideration the already halved resolution in Darktable though. So by taking that into account, it's like 4x optimization already. In addition to that, there is a whole bunch of advanced parameters which I really don't recommend touching. The developers of Meshroom don't recommend tweaking it as well. So let's listen to them. It's simply not worth it. Alright, calculating the depth map now. There should be enough time for a cup of coffee or green tea if you're up for it. In order to predict how long it will take, we can once again check the log. Each chunk that has been processed shows the time that it took. So to approximate the remaining time in a kind of a rough way, we can multiply the time as seen in the finished chunks by the total number of chunks. For example, we can tell that the depth map chunk number 12 took approximately 19 seconds to complete. And then let's say we have 35 chunks in total. That means 19 multiplied by 35. What is it? 660 seconds or 11 minutes. It is a very rough ballpark though, because chunks can take different time to calculate, but that gives us some figure to work with. Allow me to fast track the result though. Anyway, it took about 11 minutes indeed. I think it's actually pretty fast because we have downscaled the sources in Darktable, remember? That is so totally worth it, downscaling. If you feel like waiting a little bit longer, and potentially getting more detailed result in the end, then just feel free to bump the downscale value all the way to 1. It is a little bit scary though. Anyway, I'll proceed to calculating the depth map filter node, which is really quick to calculate as opposed to the depth map node. Alright, so with the depth map calculated and filtered, it is a high time for materializing the 3D model itself. The colorized output can be turned on if you want to check the vertex colors, but I don't see a real need for it right now. Then we should probably consider switching on the custom bounding box within the meshing settings. That would really help to cut the garbage and optimize the reconstruction speed. Right away we see no change after ticking this checkbox. That's because we need to double click on the meshing node, that's important. And then we should see this new model in the scene tab. And we can hide the bounding box if needed by clicking on this icon. Alright, so we can adjust the reconstruction region by manipulating this gizmo, but it's somewhat obstructed by this second display gizmo. Thankfully we can disable it by clicking on the display trackball icon. And now we can move, rotate and scale this thing so the bounding box encapsulates our mesh in the most optimal way. Like, do we really need to render everything or just this clothy object? Maybe we can save some resources by constraining it like that. Sometimes it's a life-saving optimization if, for example, you have scanned the entire city area and you want to render just this building. Okay, with the bounding box ready, we can go ahead with the mesh reconstruction. That is pretty exciting. We will see the fully fledged photo scan, the fully fledged 3D object for the first time, and we will tell if it's good or not. Of course, I already know that, but anyway. I will disable the bounding box, re-enable the trackball in the viewport, and what can I tell? Except these floaters at the bottom of the model, everything else looks great to me. Actually, better than I expected. This is our photo scan and it is actually good. I'm really happy with it. Now we can either proceed to the very end of the chain and do texturing, or we can do the cleanup in Blender and then do texturing instead. And that's probably what I'm gonna do, because I want to change a few things with the mesh. So after creating the publish node, I'm connecting the mesh output into the input files, and then the output folder needs to be selected. We can do it like this, at least in Windows. After opening the folder, right-click on its name, copy address as text, and then paste the text over there in the output folder field. And lastly, right-click on the node and compute. After that, an OBJ file that contains our high-poly mesh should appear in that folder. In just a moment, we will bring it into Blender for some cleanup.